Hello everyone! I have recently been in the mood to get a bit into cybersecurity again. And I thought that a fun challenge would be to try to create my own little login panel, as you can see here, but purposefully make a bunch of mistakes that I can try to teach myself how to exploit. In this case, we have a login panel here. We can write in some numbers, and if the password is wrong, we will not get in. If the password is correct, it will show us that the password is correct. I will start off a bit more simple here, just try to see if I can figure out what the password is, but later I'm going to try to see if I can use some memory manipulation to be able to get in. So let's start by looking at the most obvious thing. This password, in our case here, consists of 5 different numbers, and for now we'll just assume we can only use numbers, meaning that each digit in this password can represent one of 10 different values, 0 up until 9. This means that the maximum number of different combinations we can represent is 10 to the power of 5 different combinations, or in other words, 100,000, 0 being the lowest and 99,999 being the highest. This might sound like a lot, but now let's just try and brute forcing this, writing some Python code that can automatically loop through this for us. So now I wrote a bit of Python code. I think maybe in total this took me somewhere between an hour and 2. The only thing that really took long was, for some reason, using normal backspace just did not work, and I had to use these kind of odd approaches instead. Not entirely sure why, but it's fine. Using the library PyAutoGUI, I am able to tell the mouse where to move to write some text, move to the login button, click it, and then delete the text and try another combination. And it will just continue until it reaches the highest possible number to show. Now, using this code, we are able to automatically type in a password, delete, and try again until we find the result. And because I have no checks on how many attempts I use to log in, and I just allow the user to do as many as they want, they can effectively just keep brute forcing it until they get one that goes through. Now, if we look here at how much time it takes roughly 1.61 seconds on average, with a few exceptions, to type in the password. That means that in a worst case, if we try all 100,000 different combinations, assuming checking each one takes 1.61 seconds, then divide that by minutes and divide that by hours. That would mean that in a worst case scenario, using this approach, it would take 45 hours to check all the different combinations. Now, this is a long time and I have other things to do, so maybe just let's quickly change this to something a bit more simple, like let's say 200 here. The password is 200. That way, it should not take as long. So if we say we need to try out 200 different combinations, divide by 60, divide by 60 again. Okay, not even necessary. 5 minutes. Okay, 5.36 minutes. Okay, let's test it now and see if our prediction fits. So we start the login panel and we run the script, start, and move this. Let's see how long it takes. I was fairly close to expected. Even though this definitely took a while due to my shitty code, someone that knows what they're doing would get through this in no time, and the number of combinations that are available here is too small. But if you, for example, instead of only using numbers, also added letters, the number of possible combinations increased dramatically. Then you add maybe on top of it special characters and more digits, and you end up with a number of combinations that is very difficult to actually test. Now, the second vulnerability I want to try and explore is the fact that I have the string password here saved as a variable inside of the program, and the fact that it's not encrypted. The reason this is a problem is because all our variables defined in our program here will get added onto our RAM, and it is possible for us to access our RAM by other means. So, for example, the variable screen width, while it might not be called screen width, in the end it will just have some kind of address. It will have the number 800 in there. So if we filter out all numbers in there with 800, one of them will be the screen width. And the same goes for our password. Now let's make this a little bit more interesting and choose some kind of password that's a bit less easy to guess. That's the one character too many. We have a maximum of 5. Now, just for visualization's sake, I have used a program here called pins. If you're on Windows, you can use something like Cheat Engine, does effectively the same. This allows us to find some kind of process that is running, our flawed login page here, and see which variables it has in RAM. So for example here we can go for strings, we don't know exactly which one, and look through. In this case you can see there is a lot of options here. So we need to filter this down a little bit. We can also do this by looking at the binary itself. So if we look in this folder, here is the flawed login page, which is the binary that gets executed. We can use a command like strings, and like we saw in the program before, this returns a heck of a lot of options, so it doesn't really help us that much. But if we only know a few of the characters in there, so for example, let's filter out all of them that don't have an exclamation point. Well, now you can suddenly see that the list is actually kind of manageable and within a realm that is possible to sort of guess. But let's say we know even one more character. We know there's an A in there. Now there's even fewer. And as we can see here, there is variable here. This could be a valid password. This could be a valid password. This is definitely code. All of this and this one, which is our actual password stored in the binary itself. So it would effectively at most take me 3 guesses if I was just able to just know 2 of the characters to get a valid result here. Now for the last approach I want to show you, but probably the most interesting. I made a big mistake here by having this boolean that says whether or not login was successful, that is not dependent on the frame or gets reset besides from clicking the button. So the way I implemented this here is that I here have a check, did we click the login button, and if we were successful then it's set to true. And then later in the code we have a check here, if it's true, draw the green text. This might seem intuitive, but it leads to some problems, which I'll show now. So as we discussed before, all of the variables in your code will end up in RAM. And since we have a boolean that tells us whether or not we have successfully logged in, this will also be in RAM somewhere. In C++, when a boolean is compiled, it will typically turn into an integer 8. And at this point, let's just try and click enter. Right now, we did not click in the right password, so this will definitely be a false, which means that we need to search for integers in our RAM that is used for this application that contains the value 0. As you can see, this returns a lot of values. However, we can already now reduce this by just keep checking, because some of these are related to processes that keep running. So we can see here this keeps going down as I search. But to change this even more, let's try and actually log in. So now it is a 1. Then let's try and check. Is there any of the boolean values or int 8s that was 0 before but now is 1? That got significantly reduced suddenly. Now let's try again here, make it false. Then search for all the zeros now. Even more so. Let's see if we reduce even more. Okay, that disappeared 1. Let's try one more time. Now let's search for the ones that have 1 in there. Only 2. And I'm pretty sure now, if we click here, this one turned into a 1. Or a 0 suddenly. So, both of these, one of these must be related to the password. Let's try and get access to this. and forcefully change this from a 0 to a 1. Oh, password correct. So now we know that this address in RAM is related to this variable, and by just changing this variable without actually writing in the password, we are able to log in and log out. Thereby, it's a big vulnerability. But that was everything that I wanted to talk about for now. I am by no means an expert in this, but I find it interesting to look into and talk about. I hope you found this interesting too. Thank you for watching, and I hope to see you next time.